Hello everyone. Today I'll be talking about carbon, nitrogen, and oxygen nucleophiles and their reaction with carbonyls. So first we're going to begin by telling you the types of nucleophiles. So we were talking about oxygen, nitrogen, and carbon. So some of them include water, an ROH group, an OH group, and an RO group. For nitrogen, we have NH3. We have this nucleophile. And this one with two R groups. And this one has that one too, but this one also has hydrogen. And then for carbon, we have this R with the ligand, a cuprate, and a C. So first we're going to go with the oxygen nucleophiles reaction with carbonyls. So I'll just put oxygen with carbonyls. So if we have water react with this ketone, we should get this, which is a hydrate, or in general, a diol. And then we can also do a quick mechanism for this example. We have this one equivalence with this molecule. Like, what do we get? Okay, so we have this ROH, and we have our molecule. So this is delta positive, and this oxygen delta negative, because, it is. And then this R group is going to get attracted to this carbon here, which would then make this double bond go back to the oxygen. And then this hydrogen will also come off of the oxygen to give us this molecule, H here. Then we have this RO group. And then this hydrogen comes back, because what left was the hydrogen. And then we have that here, which will then attract that, which will ultimately give us the product of a hemiacetal group, because there's one OR group and one OH. And if you were to do this again, let me put the answer here. And if you were to do this again of one equivalence, you would get an acetyl group, which is two OR groups. So we could put that over here. Hemiacetal. It's one OR group and one OH. And then for acetyl, there's two OR groups. Yep. And then we could go on to the next one, which is nitrogen. So for nitrogen, I'm going to show you just some amines that we have. So we have R, NH3, we have R, NH2, we have R, N, R, and then a hydrogen, and then we have nitrogen with 3 R groups. So in general, we could say this one is primary, this one's secondary, this one's tertiary. Once again, these are all amines. I'm going to show you what one amine reaction with carbonyls looks like. So if we were to get our NH2, this is primary reaction. That plus this group here, water will leave. Then it will give us the product of an amine, imine. So this is an imine, which is from the Schiff base. And then I'll just show you a mild acid mechanism for nitrogens as well. So this is mild acid. So we have this ketone plus NH3. And then we have this H plus here. We should get something that we're going to figure out using the mechanism. So first, we're going to get the NH3 and react it with hydrogen with an acid. With an HA. So this nitrogen is going to get attracted to this hydrogen, and then this bond will go back to the acid, which will then make H minus this leave. And then we can actually draw what it gives us. This nitrogen has a positive. Then once again, we have this ketone, which is going to get attracted to this hydrogen, which will give back this bond to the nitrogen. And if we keep going, so now we have this, and then this oxygen has a positive. We're back to having this NH3. These bonds are going to be attracted to this carbon because it's delta positive, and then this oxygen is delta negative. And then this double bond will go back to its oxygen. Then we will get this NH3 right there, and then the OH here. And then we keep going with another NH3. And then once again, these bonds are going to go to this hydrogen. We'll give back to the nitrogen. That'll give us NH2, and this is an OH. And then that plus the NH4 that we just created from here, we have N, H, 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 H. So this oxygen, we're gonna get to this hydrogen, give that bond like always, and then we'll get NH2 here, and then we'll have water here. This oxygen has a positive. Then we keep going. This nitrogen, and give some of its bond to this bond here, and then this bond will actually leave, so water leaves, which will then give us this with, water on the side because it left. And then remember, this acid here is coming back. Then we have this acid here, which will attract to this hydrogen and give back that to the nitrogen, which will ultimately give us the product of this. And don't forget the stuff that we just made. So the hydrogen with the acid and the water. The answer to this, once again, is just that plus water plus this acid. Now we're gonna keep going to the carbon with carbonyls. And here, if we have this product, this molecule reacting with KCN and hydrogen plus, we know, like always, this is delta positive, this is delta negative. So these bonds on this C, they're going to be attracted to that carbon there, which will break one of these double bonds to give it back to the oxygen, which we will get CC, because, CN is just that. No, right? That, I think. And this carbon will just have its regular groups that it had originally. So the R, the H, the oxygen, because the oxygen didn't leave yet. And then we need to protonate the oxygen, so it's going to get attracted to this hydrogen, which will give us the product CN here and OH here. We still have our R group and we still have our hydrogen. And that is it for the carbon, nitrogen, and oxygen nucleophiles and their reactions with carbonyls.